This is a thermochemistry problem in which hot water is added into cold water and we want to calculate the final equilibrium temperature. This is from page 277, number 53 of Zundel 8th edition. A 30.0 gram sample of water at 280 Kelvin is mixed with 50.0 grams of water at 330 Kelvin. Calculate the final temperature of the mixture, assuming no heat loss to the surroundings. So here is our beaker with the 30 grams of water at 280, and this is our beaker with the 50 grams of water at 330 Kelvin. So we are going to assume that both of the beakers are our system, and there is no heat loss to the surroundings, so no heat is going to get into or out of the system of the two beakers of water. But because our water has different temperatures, there will be a heat transfer from the water at the higher temperature to the water of the lower temperature. Remember that neither of the beaker has heat. Heat is energy transfer between substances of different temperatures. So because our system stays the same in terms of heat, we can say that the Q of the cold plus the Q of the hot is equal to 0. The cold water is going to gain in thermal energy. The hot water is going to lose thermal energy, but they are going to come to a final temperature, and the magnitude of the heat gained by the cold and the magnitude of the heat lost by the hot will be the same, but they will be opposite in sign. We could also say that the Q of the cold is equal to the negative Q of the hot. In class, I think I used that form, but today I'm going to use it in this form here. So now we can just plug our MC delta T into the equation. So the mass of the cold times the heat capacity of water times the change in temperature of the cold plus the mass of the hot times the heat capacity of water times the change in temperature of the hot is equal to 0. So we can divide by the heat capacity of the cold. It's the same for all, so we can cross that out. And now we can plug in the mass of the cold, 30.0, times the change in the temperature. So change is always final minus initial. We're looking for the final temperature. The initial temperature of the cold is 280 decimal point Kelvin, plus the mass of the hot, 50.0 grams, times the change in temperature, T final, minus our initial of 330 Kelvin, and that equals 0. So we're going to get a negative term here and a positive term here that are equal in magnitude, opposite in sign. So now we need to solve this. We have one variable in our equation. So if you have a TI-89 or similar calculator, you could use your solve function, but I'm going to go ahead and do the algebra. So we need to distribute first. So we get 30.0 TF minus 30 times 280, which is 8400, plus 50.0 T final minus 16500 equals 0. So now we're going to collect like terms. So we get 80.0 T final minus 24900 equals 0. And that leaves us with 80.0 T final equals 24900. So now we solve for T final, and we find that T final equals 311 Kelvin. So notice that that answer is in between the initial temperatures of the cold and the hot, and the 311 Kelvin is closer to the initial temperature of the hot water because the hot water has more mass. So there is our answer.